I'm back working on the Hazeltine 2000 smart terminal. In the previous video I was looking at the monitor, and I also mentioned in a previous video that I had more than one of these to repair. And what I've been doing is, although I haven't shown it on camera, each time I've tested a particular board for the unit we're looking at, I've then followed that up by testing the same board in the second unit. It just saves me having to set everything up twice, and hopefully will result in two working units. And what I found is that the monitor drive board in the second unit isn't working, and I thought we'd take a look at that in this video. Before we get on to that, just to field a couple of comments from the previous video. Get a lot of complaints on my channel about things like monitors making whining noises, and I should do something about it. Well, that's the noise they make. These videos are repair videos. I shoot them as I repair. They are not staged to make YouTube videos. These are real repairs, and the noises are what the machines make, and it's part of what you have to put up with if you repair and work on this type of machine. I'm not going to filter it out unless there's a very specific need to, but in response to the previous video I had a few complaints saying that it's a horrendous noise and somehow trying to blame me for the noise. Well, I didn't design this. This is just the nature of what these are and the noise they make, and it's not unusual for them to make noise, especially when you run them outside of the machine when the timing's not perfect for them. But it's what they do. It's not that unusual. And someone said that this weird noises, all mixed noises. No, it isn't. It's just the line whine, as I pointed out in the previous video. Somebody even said, could I really not hear it? Well, I pointed out in the video that it was making a whining noise, so I don't mind comments, but at least watch the video before you make a comment. Also, the noise was just a single tone at 17 kilohertz, which is the frequency I was testing at, and as you can see in this spectral graph for the particular board we were looking at, it's just a single spike. This is an average, so it's giving you kind of worst case, but it's quite low amplitude. It's I mean, it was very audible, of course, but that is just the nature of these machines. If you want to work on machines like this, it's something you have to put up with. And unfortunately I can't get smell across on the videos, otherwise I would include that as well. Machines like this, or that are older and may not have been run for half a century, can emit some fairly interesting aromas, but it is the nature of working on vintage equipment, so it's something you have to get used to. If you're not willing to tolerate it, then chances are you're just not interested in the subject matter, so no harm, no foul. But if you don't want to listen to it, just open the mixer on your playback device and turn down everything above 6 kilohertz, and then you won't need to listen to it. I'm leaving it in simply because it's part of the experience of working on these machines. So that said, we'll get back to this board, try and figure out what's wrong with it. Got it hooked up to the bench supply, as you can see, set to 12 volts, current limit at 1.5 amps. Should draw about an amp. You saw that on the previous one. And when I turn this on, now of course I don't have the deflection yoke and the inductor plugged into this, so it's not going to run, or not going to try and run. But if we look at the schematic, I don't have a schematic for the Hazeltine, but I do have a schematic for this particular monitor. And what we can see here is we've got two basic circuits. We've got one for vertical deflection, and we've got one for horizontal deflection, or the line. And because the line runs at fairly high frequency, about 16.7 kilohertz, then it's used as kind of a flyback high voltage generator to generate the EHT for the tube around 12 kilovolts, but also the what amounts to a B+. There's no real B+ as such in this, but this is the closest you're going to get to it, and the plus 400 volts that's used for various other parts of the tube drive. The same circuit also generates minus 160 volts that's also used to properly bias the tube, and this is not free running, it doesn't freewheel, so when there is no horizontal drive poles, this should do nothing at all. It's all based around a transistor. This is, you probably recognize this circuit. If you forget this is a yoke and just look at it as an inductor, then you'll probably recognize this as being kind of a switch mode power supply. And that's really how this works. So what we have is a single transistor here, and it's a PNP transistor, and the base is controlled through this transformer, which is this small transformer on the board. And the transformer is not open circuit, I've checked that, so neither is the resistor. So what should happen is we've got the 15 volt rail here, and the way this is arranged, we have a path to ground through this coil, which is one of the windings on the EHT transformer. It's the primary winding on the EHT, and with this unplugged, which it is at the moment, there should be no current passing through this circuit because the transistor should be off and the diode should be reverse biased. So if we look at this particular connector, which is this connector down here, then we've got this powered up. You can see the current being drawn is very low, but if I put a link across these two pins, then notice the current maxes out and it goes up to 1.5 amps, so just a few, drags the voltage down to a few volts, because we do have this resistor here. Without that there, the current would have kind of shot off the scale and the voltage would have dropped to pretty much zero. So there's obviously something wrong with this, because this is the connector I was shorting out, and all that should have happened is nothing, because this transistor should be off. There's no drive coming into this, so there should be nothing coming through here, and in that idle state there should be no current flowing in this path. So there's something wrong, either this capacitor, and this isn't here of course either, so either this capacitor short, this diode short, or the transistor is short. So they're all in parallel of course, so we can't easily tell which it is. So what we'll do is we'll start with the easy one. We'll pop out one end of the capacitor, see if it's still shorted. If not, we'll move on to the diode. Start looking at this. We'll pop out the capacitor first, or at least one end of it, see if the short goes away. If not, I'll take out the diode and we'll test it out of circuit. So I've desoldered one end of the capacitor, so that is this capacitor here, C109, and we'll see if the short is still there. So if you measure across that point, and as you can see we still have a dead short, and if I reverse the probe leads just to show that it's not a diode that's conducting, we can see we've got a dead short there. So I'll now try taking out the diode and we'll see if that removes the short. I've removed the diode, so we'll test that out of circuit. In fact, we'll buzz across this first, and unfortunately the short still seems to be there, so we'll try measuring this and see if it still behaves as a diode, which it does. The strange voltage is because this is a germanium diode of course. So that's fine, and that just leaves the transistor. So I'll pop this out of circuit, and in fact now that the other two parts are removed, we can actually test this with it still soldered to the board. So we'll see if it behaves. And as we can see, it is a dead short. So I'll take it out, just confirm that, and it does appear our transistor has gone short. I've removed the transistor from the board. We'll just check on the board to make sure that the short has gone. It has. And we'll now test the transistor. It should be a PNP transistor. So base to collector, base to emitter. And reverse and do the same again. So that doesn't really look right. And then emitter to collector, which is where I suspect the problem is going to be, and sure enough we have a dead short between emitter and collector. So the transistor has failed. It's marked as a B1182, and I'll need to try and dig one of these out. So we'll try and find something with maybe a slightly higher spec, and hopefully it will survive more than the 40 years that this one did. So I'll go and look in the parts bin. If I can't find anything, I'll need to get something on order. But luckily the diode is still fine, capacitor's fine. And another question I got on the previous videos was whether I shotgun capacitors, and the answer is no, I don't. I don't, as a habit, replace all capacitors, and I don't see a need to do that. I've had very few issues with capacitors failing, and normally I will check for leakage, ESR, capacity, that sort of thing, but I don't just routinely change all of them unless there's a particular need to. I'll do that on old valve equipment if it's from the 1940s or 50s and it's got paper and aluminium capacitors, then yes, I will generally shotgun those, but not on something this recent. I don't see a need for it, and you can do it if you want. It certainly won't do any harm, but it's not something I routinely do. Okay, so the next thing I have to do is find a transistor for this and get that replaced and hopefully bring this back to life. Once I do that, it will start making a whining noise. Be prepared for that. Either buy some earmuffs or do what I do and get used to it. It's part of the penalty you pay for working on these old machines. So I've replaced the transistor. I've put a slightly higher spec one in. Unfortunately, I don't have any AY102s, so I've had to refit the 106. It should work. It's been there for 40 years, so hopefully it'll keep working, but if I can find any, I will sort that out with an AY102. So this is the transistor we've replaced, and we found before that when we shorted out this connector, we got current flowing, and we shouldn't have done. So we'll try the same thing again. I've got it reconnected. We'll power it up, drawing the same standby current it was before, about 25 milliamps. But this time when we short this out, it shouldn't max out the current limit. And as you can see, it's making no difference, which is what it should do. It should not conduct. The transistor should be biased off without any horizontal drive, and it is. So what I'm going to do now is refit this to the CRT monitor. We'll power it up and see if it works. I've got the CRT driver board refitted to the chassis, and I've got the signal generator hooked up to the video in. We don't of course have the video control card or video output card fitted to the rack, so we need something, otherwise the raster would just stay blank. So we'll try and power this up and see what happens. Okay, well, no magic smoke so far, and it should have had long enough to warm up, so we'll try switching on the signal generator and we should get a pattern of some sort on the display. And indeed we do, and considering it's just had a new horizontal output transistor fitted, it's quite a reasonable output. Try turning the brightness up. That works well. We'll try, the focus is out a bit. I still think this tube needs to run a bit longer yet. We'll try increasing the frequency of the signal we're feeding in. Input signal that we're applying, we're getting suitable patterns, or patterns that we would expect to see based on what we're feeding in. So that's all looking very good. The tube is now getting quite nice and bright. The focus is out, and as I say, there is a focus control on the control board, and I'm not going to touch any of these setup until the system's showing some text out of the actual controller board, because it will change the way that the display works. These are very simple driver boards, and they're very reliant on the control signals that you feed in. It's not like a PC a CRT monitor that you used to get with multi-sync. These are very dependent on not just the sync signals but also the data being fed to them. Okay, so the last thing we'll do in this video, we've now got this working, is I'm just going to put a laptop alongside that's running some audio analysis software. You'll see this is nowhere near as loud as some of the comments seem to, or commenters seem to think it is. So I'll just get the laptop set up. Okay, so we have the laptop set up. As you can see, it's responding to my voice, and I'll stop talking in a second, but the area we're interested in is up at about 16.75 kilohertz, which is right off to the right hand side, this approximately where this spike here is. But I'll stop talking and we'll see what the nominal level is in the lab here. So as you can see, the noise output from the CRT display is very low. It tends to be noisier when you run it through signal generators, because we're kind of away from the sweet spot for that particular system, and they are designed to work over a very limited range of frequencies. But even so, it's nowhere near as loud as many people seem to be under the impression that it is. It does whine. They always whine, and if you've got sensitive hearing, especially at the high frequencies, then of course you're going to be able to hear it. But it's one of the things you had to tolerate back then. But we're down, when I don't talk, we're down about minus 120 dB, which is extremely low level noise. It's almost imperceptible. The microphone on the camera does tend to make it sound a lot worse than it is. The microphone response is not linear, but as I say, I'm not going to get too involved with that. This is part of what working on these machines is about. Okay, so you can see that we're making progress. We've now got the monitor repaired and back up and running. The original board that I had fitted, there are still some issues with it, the control board I'm talking about for the CRT, in that it is making a bit more noise than it should, but that is actual mechanical noise. That was down at 8 kilohertz, and that's because one of the inductors was broken off the board, and it was kind of resonating and buzzing, and most of what you could hear was a buzz from that rather than the actual high-pitched flyback whine that you get. But it won't do that once the board is secured to the chassis. At the moment it's just sitting on some standoffs, but I have got some clips I'll use once I'm happy that it's working properly.